Namaste everyone, my name is Srikanth. I'm an assistant professor in Methodist College of Engineering and Technology, and this semester I'm handling the subject of engineering graphics. Now, handling the engineering graphics subject within a small uh, time available within the class and covering whole of syllabus and of course the whole of doubts of the students seemed a very difficult task, and that's the reason why I'm here with a slightly new approach to teaching. Here now you are having my video which I recorded earlier today premiering on my YouTube channel. So you're all watching this. You can also go back to the time and rewatch parts that you don't understand. So I won't have to repeat myself again and again as it happens in the live classes. So students can take up the class at their own pace, try to understand from the video. And if you are having any doubts from the video which they cannot understand, they can of course come back to the Microsoft Teams where I'm available live to clear your doubts. Thank you. Okay, so without waiting much, let us continue with the today's class. In the previous two classes, we covered the plane scales as well as the diagonal scales. Now the plane scales, I was able to record the complete class and the video will be premiering today in the evening around 4 or 5 o'clock. So make sure you attend, those who had not attempted that class, those who were absent for that class can rewatch the same class premiering on the YouTube today at 5 o'clock. So, and the previous class I didn't record probably because diagonal scale was the only problem we covered, and for this problem I had already recorded a short video explaining everything right from the introduction of the diagonal scales to the solution of the problem. So they can watch that problem again. It's already available in the YouTube channel, the link to which also I have shared to you. And today we are going to start learning about another kind of scale that is called as the Vernier scale. So let's proceed. First of all, I would like to explain to you what the Vernier scale is and how it functions. So this is what a Vernier scale looks like. You may think that it is exactly like the plane scale, but there is a lot of difference between these two. Let me keep the plane scale and the Vernier scale side by side for the difference to actually come out. Okay, so here we have the two scales. The scale that you see above, the scale that you see above is the Vernier scale, and the scale that is here below, that is the plane scale. Now both these scales have the same representative factor. The representative factor is 1:40 for both the scales. Now this is a plane scale and this is a Vernier scale. Now the first difference that you will notice is that the plane scale, in the plane scale, only the first main division has been subdivided, whereas in the Vernier scale we'll have to subdivide all the main divisions. That is the first difference, but that's not the only difference. This scale, which you can see at the bottom here, is the main scale. What makes this scale different is the Vernier scale that is attached here at the top. Now let me explain what a Vernier scale is. So this is the main scale, right? So the distance between these two lines is exactly 1 meters, which is divided into 10 parts, which means the distance between each of these subdivisions is 0.1 meters. Now the challenge in measuring more precisely is that you want measurements which are 1/10 of 0.1 meters, and that's what makes possible, that's what is very easy to do with the diagonal scale. But there's a very big problem with the diagonal scales, and the problem is that they take up a lot of space. So in order for us to save this space, what we have to do is we got to use the Vernier scale. So you can see that the Vernier scale takes up exactly as much space or a little more space if you consider the Vernier scale, but it offers the same precision that a diagonal scale allows us to do. Of course, that complicates the procedure for marking the distance for a case, but no, that's okay. To gain something, we have to lose something always. That's how life is. So anyway, so let's go ahead and see what this Vernier scale is. So what Vernier scale, what happens is I take this same distance, 1 extra. Fine. So as I told you, the distance between these two lengths is exactly 1 meters, and the distance between these two lines is 0.1 meters. So when I take this length exactly extra on the other side, the total distance between these two becomes 1.1 meters, 1.1 meters. And that 1.1 meters we are subdividing into 10 equal parts, 10 equal parts. So what happens there? Okay, so we are having this total length, the distance between this point and this point is 1.1 meters, and we are making 10 divisions into that. So each of this length, how much is going to measure? That's going to measure 0.11 meters, 0.11 meters. Now this is what makes the Vernier scale different from the main scale. So this here is the main scale. Okay, main scale and the Vernier scale. That's what is the difference. That's what is the difference between the two scales. Now when the one division is going to measure 0.11, then two divisions are going to measure 0.22. Three divisions are going to measure 0.33, and so on. Right. So this Vernier scale helps us in eliminating the last digit, the last digit. So let us say, for example, you want to make a measurement of 1.12 meters, 1.12 meters. So we are going to measure this in two parts. So in the first part, we are going to eliminate this last digit. How we are going to eliminate this last digit? By matching that with the last digit of the Vernier scale. So if you want to eliminate 0.02, fine, no, 0.02, this last digit 2, if you want to eliminate, you have to take two divisions. You have to take two divisions on the Vernier scale. So when you take two divisions on the Vernier scale, it's going to measure not 0.02, it's going to measure 0.22 meters. Fine. So you got to take the line here. You got to take the starting line here. Fine. So from this point up to this point, it's going to measure 0.22. 0.22. Fine. Next, we'll have to mark the remaining distance on the main scale. So how much distance it is going to remain from this? 1.12 minus 0.22. This much distance is going to remain. So this distance we have to mark it on the main scale. So 2 minus 2 is 0, and here, okay, 11 minus 2 is 9. So 0.9 we are getting. So this 0.9 we are going to mark it on the main scale. 0.9 means it's going to come up to here. So this point, from this to this distance is 0.90. So 0.22 here to here, 0.90 here to here. So the total distance from this to this, how much does it measure? So that measures 1 point, how much did we want here? 1.12, 1.12, the distance that we wanted. So this is how measurements will be made in the Vernier scale. Fine. So we have to always divide whatever length we are asked to mark into two parts. Fine. So the first part is supposed to eliminate the last digit. And once that is eliminated, the length that is left will be the length which we can mark on the main scale. Fine. So that's how, with the combination of these two measurements, we will be able to mark whatever length we are asked to mark. And look at the precision that this is offering. The precision that this is offering is much more than what the plane scale is offering. So in the plane scale, the best we can mark is 4.7. But here, we can go ahead to one more digit. We are able to mark 4.76 meters as well. So now with this, there also comes a question. What if you want to mark a distance which is less than 1 meter? Well, that as well is possible around here. So let me explain how we mark 0.46 meters. Okay, So let us say we have to mark a length of 0.46 meters. Now this is of course less than 1 meters. So how do we mark that? So once again, first we should eliminate the last digit. So in order to eliminate the last digit, what we have to subtract? So we have to take 0.66, which is possible with 6 Vernier scale divisions. So 6 Vernier scale divisions are going to provide us with 0.66 meters, and when we subtract this from the mark which we have to mark on the scale, that leaves us a negative value. How much value is left out? Let me be safe and use the calculator. 0.46 minus 0.66. So that leaves us minus negative 0.2. 0.2. Fine. So now when we have to mark this, what we have to do? We have to take 6 divisions on Vernier scale. So 1, 2, 3, 4, 5, 6. So this is the Vernier scale mark that we have to take. And on the main scale, the marking is negative, which means we have to take this line here. Fine. So this line here is the negative 2 minus 0.2, sorry, minus 0.2. So this is minus 0.2, and this point to this point, this is 0.66. So the net distance between this line and this line over here, this will be 0.46. So this is how you can mark off distances which are less than 1 meters. Fine. This is how you can mark off distances which are less than 1 meters. So I hope you have by now understood how to use the Vernier scale. Now let us learn how to draw a Vernier scale in AutoCAD. Fine. So the question here is very simple. It says we have to use a representative factor of 1:40, and we have to draw the below mentioned scales long enough to measure 6 meters and mark lengths which are mentioned in the points. And there are 2 types of Vernier scales mentioned here. One is the positive scale, the other negative scale. So in this video, we're just going to cover the positive Vernier scale. Negative Vernier scale we'll probably do some other day, or I'll just make a video on that and make it available to you so that you can watch and learn from it at your leisure. Okay, so let me just delete whatever is not needed, and I will draw that Vernier scale. Okay. So let me just push it down this. Okay, I'll just delete this and I'll create it once again. Fine. So you can see here that the first thing we have to do is same as the rest of the scales. First, we have to use the value of RF to find. We have to use the value of RF to find the drawing size. From the actual size. The actual size is 6 meters, of course. RF value is 1:40. So the drawing size can be found by using this formula. I've substituted the values here in the step. You can see, and 15 centimeters is again the length that we have to draw. So let us begin. So we have to again start with the line command, L02. Then I have to click on the left side somewhere, and then have to turn on the ortho option. Ortho option I have to turn on. You can also use the shortcut F8 to turn it on or off. So now it is off, now it is on, now it is off, now it is on. So once it is on, you will get exactly horizontal distances. So now we have to feed a length of 150 mm. Now we have our 15 centimeters ready, drawn on the drawing sheet. But actually this length is 6 meters. It's not 15 centimeters. 15 centimeters is what we have drawn. But this 15 centimeters is representing a length of 6 meters. So now we got to make 6 divisions on this line. So the command that we have to use is div, enter, then click on the line and then press 6, enter. Wherever I'm telling enter, you can also use spacebar. Both will do the same function. So you can see some points are placed on this. 5 of the points are placed, which are dividing this line into 6 equal parts. Now, for some of the students, if they are especially using AutoCAD for the first time, the points will not appear properly. So if the points are not visible, I suggest you to use this command, ptype. So you have to type ptype, and you can see here there are a lot of different symbols uh, available for representing the points. So by default, this is how it will be. So even when your points are actually made, even when the line is getting divided, the points are not going to be visible to you first. So if such is your problem, you just have to give the ptype command and choose one of the symbols, whichever is convenient, whichever is to your liking. You can select that, and this here is the size of the point that is visible on the screen. I suggest you to use the absolute units and mark the point size as 2 or 5. Between 2 or 5, whatever is convenient to you, you can use it. Okay, so now our main line has been divided into 6 segments. Now what we have to do is we just have to build this line. We will take 1 centimeter as the thickness of the scale, 150 back, and close it. Now I'll just copy this line, CO, enter, pick it from here, and go on placing it at all these points. Fine. So now our main scale is ready. Now we have to subdivide the first division. Now you might tell me that we have to subdivide all of these divisions in the Vernier scale, but we will just start with one of them, and then we can just copy them off to all the other points. So let us proceed. Once again, I'll give the divide command. Take this line at the center, not this line. If you select this line, the complete line will be selected, and this is what you will get. We don't want that. So I have to give the divide command, div, select this line, give 10 parts, enter. So you can see the 10 parts are created over here. Now let me take line from this point to perpendicular. So if these yellow points are not visible to you, like the end point or the midpoint and other stuff, make sure object snap is on. If object snap is off, you won't be able to see those points, and your line may end up at some other place. Fine. So if this is on, it will display the points exactly, and your cursor will jump to exact spots. Then I will just copy this, select the line, CO, enter, pick it from this point, and go on placing them at whatever points you want. Once you have placed the lines at all the places, select all these points and delete them because we don't need them any longer. The middle line, I can extend this slightly beyond this center so that I can identify it as the middle line and start counting from here. Like if you want to mark 7, I don't have to count from here 1, 2, 3, 4, 5, 6, 7 like that. I can just start counting from here. 5 is this one, so 6, 7. So that's what saves us some time and makes it convenient for us to count. Once these divisions are made, I can just copy all these divisions. So select all these lines, CO, enter, pick it from this corner over here, and go on placing it on the next corners. So that's our main scale. So now main scale is ready. The next thing that I have to do is I have to build the Vernier scale. So watch this carefully, how to draw the Vernier scale. So first what I have to do is take offset command with O enter. After O enter, I have to click this point and this point. So what this will do is whatever is the distance between these 2 points, these 2 endpoints, that same distance will be recorded by the offset. And then I have to click on this line and click on the left side. Fine. So if you have any confusion, if you are not able to understand this, you can just rewind it 2 seconds back, watch it once again, try it until you are perfect with this. So once we got this distance extra on the left side, next what we have to do is we have to take this join here with a line, of course, and then for vernier scale, we will take slightly lesser height. So I'll just go with 8 mm. You can also go with 5 or 6. It's okay, no problem. And then I'll have to draw a line up to now exactly here. I just have to keep my cursor here for some time, and then you can see that the line is snapping exactly to that point. So if this is not happening, that means the object tracking is set to off. Fine. So of course the object snap has to be on. If it is not on, then no matter how much you stay here, this point will not appear. So make sure object snap is on. Keep your cursor here on this endpoint for some time, and then go up. You can see that line is stopping there exactly. Click there and then join here down. Now this line here should be complete line, and this line is what we are going to make 10 divisions in. We already know the command for this. We just have to type div, enter, click on this complete line which you want to make divisions in, then feed 10, enter from the keyboard. Now you can see this 1.1 meters has been divided into 10 equal divisions. So each of these divisions is 0.11 meters long. So now I have to take this line here, copy it from this point, and go on placing it at all these divisions. Once you have placed them, you can remove the points because their work is over. So you can see that the vernier scale is now ready for us. Okay, so both the main scale as well as the vernier scale are ready for us. We just have to do a little bit of decoration. So I just have to mark this. I'll just copy the text, all these points. Then I'll double click to make changes to that. So this is 1 meter, this is 2 meter, this is 3 meters, 4 meters, and of course the last one is 5 meters. So this is the main scale, this is the vernier scale. Now coming to the points, how are we going to mark the lengths? How are we going to mark the lengths? So first length that we have to mark, let us say it is 4.76 meters. So as I told, we have to divide this into two parts. The first part is 6 divisions on the vernier scale, which will give us 0.66 meters. And when we subtract 0.66 meters from 4.76, we are left with 4.1 meters. So this 4.1 meters, we have to mark it on the main scale. So 4.1 meters on the main scale and 6 on the vernier scale. So 1, 2, 3, 4, 5, 6. So 6 divisions on the vernier scale and 4.1 meters on the main scale. So this line to this line, that measurement is exactly what we. So to mark the dimension, you should go here, take linear dimension, and from the 6th line here, we should come to 4.1 on the main scale, and this distance is going to be 4.76. That's showing 119 because this is showing in mm, and that's what we are drawing. So we have to edit this by the double clicking or pressing ED enter and then selecting the dimension, and then you can feed what distance it actually is. Fine. So we have drawn the vernier scale, we have made the marking on it, and of course there is one more mark we have to make, and that is 0.46 meters. So how are we going to do this? So we have to do it the same way as we did for this. So first aim is to eliminate the last digit. To do that, we have to take 6 divisions on the vernier scale, which offer us 0.66. So from 0.46, when we subtract 0.66, minus 0.2 meters are going to be left. This minus 0.2 meters we have to mark on the main scale, and 0.66 meters we have to mark it on the vernier scale. Once again, this is going to be our line on the vernier scale, and on the main scale we have to take minus 0.2. So from the 0 negative. So this is going to be our line. So let's go ahead and mark that. So we have to start here, and our main scale we have to start here. So this distance, again you can see it's giving us the distance in mm, but we don't want the distance in mm, we want the actual length to show up around here. So I can select it, press AD enter, delete this, and show what is the actual length. The actual length is 0.46 meters. Fine. So that's it for Vernier scale. Thank you.